Hello students, today we are going to discuss about eigenvalues and eigenvectors. Now before that, let us try to understand what is eigenvalue and eigenvector. There are several definitions given in the books, but what I feel that it is difficult for students to understand from reading the book what is the significance of eigenvalue and eigenvector. So I will not repeat the definition as it is always found everywhere in your textbooks. I just want to make you understand what is the significance of eigenvectors and what is eigenvalue. So suppose I am giving you an example, like if I have a simple what should I say, I am taking a simple 3 cross 3 matrix. Okay, a matrix which is 3 cross 3. Suppose this is it is an arbitrary matrix. I am consider this matrix as this. So let us, this matrix is 1 3 0. Okay, then it is 3 1 then 0, and then suppose it is 0 0 and minus 4. This is a matrix and this matrix is A. Now if you multiply this matrix with a column matrix, that is, suppose I would like to multiply, so the row must be equal to the column. So I am taking 1 1 1. I am multiplying this matrix with 1 1 1 matrix. So what will be the output? Output will be 1 into 1, 3 into 1, so it will be 3 plus 1 4. Then next is 3 plus 1, this is also 4, and the last is 0 then 0 and it is minus 4. So what is the value we are getting? We are getting, after multiplication, it is coming 4 4 minus 4. So if I take the 4 as common, it is 1 1 and minus 1. So that means if I multiply this matrix with a matrix, it is giving me this answer. Here 4 is basically a scalar. It is not a matrix, it's a scalar function, but this value and this value, these two column matrices are not equal. These two matrices are unequal. Okay, now suppose if I change this matrix, same 1 3 0 3 1 0 0 0 minus 4. Now if I change this matrix and if I write it as 1 1 0, what is the final value? What is it coming? It is coming 4, then again 4, and last is 0. So if I take the 4 common, I am getting that it is 1 1 and 0. So this matrix and this matrix is same. So this matrix and this matrix, when the matrix, this vector, this is a vector, this vector multiplied with A is actually is with the scalar quantity, and the same vector give you the result. If they are equal, then this matrix will be known as eigenvector. This is eigenvector. Okay, and this will be your, the scalar quantity will be your eigenvalue. Okay, so what happened, this X matrix, suppose it is X, this X matrix and X matrix is equal, instead of a dimension of 3 cross 3, it is the same equal value you can get from a scalar quantity multiplied with X. So that means if you write in a generalized way, as this was A, so if you write it as X, then what we are getting, suppose the scalar quantity is, we are taking it as lambda, that is, this is the eigenvalue, and this is again equal to X. So this is actually the equation what you get everywhere to understand eigenvector. From this equation it is written that X is the eigenvector. Okay, where A is a matrix, A is a vector, but this is a scalar quantity. So I think if you don't understand what is vector and scalar, I would like to say, suppose you know in physics what is vector. Vector is something where you can able to give a magnitude as well as a direction. Okay, so when we are going to represent that vector, suppose this is a vector in a space, this is a vector in a space. Okay, now it is from the origin 0 0. So this is X and this is Y. We know this is a 2 coordinate system. So vector should always have not only X, it will have Y, or it may have more number of dimension. If a vector is in a space have only X and Y, that means it will be a 2 cross 2 vector. That means it is having a X and it is having a Y. Okay, so if suppose, that means suppose this X is equal to 5 and this X is equal to 5 and suppose this Y is equal to 4. So what is the position of the vector? The vector position will be, this will be X is 5, so 5 and 4. So if you want to write it in form of a vector, how will you write? It will be 5 and 4. Okay, similarly if you have another vector, suppose that vector is where is my pen? Yes. Suppose there is another vector which is having a dimension of 3, x3, and y, suppose it is 1. So then what it will be? It will be 3 1. So that means here you are getting a vector which is having a 3 cross 3 dimension. That means this vector has 3 dimensions: x, y and z. X, y and z, x, y and z. Whereas when you are converting it in this form, it is only, when it is scalar, it is only having the magnitude. It is always in a same direction. Okay, there is no change in direction. So 4 is a scalar. That means if you want to give 4, so 4 will be in only one direction. Suppose it is only on x direction. So 4 is only on x direction. It doesn't have a direction in, it doesn't change its direction. That's why it is only have magnitude. Okay, so it is a scalar quantity. So what is the necessity of eigenvector? How you are getting the eigenvector? Eigenvector is a matrix by virtue of which you can able to establish this equation Ax equal to lambda x, where A is a vector, it has a dimension of n cross n, whatever it is, but this lambda will be a scalar quantity. Lambda may have more number of values, but lambda is a scalar quantity. Okay, so this is the basically physical significance of a eigenvalue and eigenvector. Now you can understand, as lambda here, lambda is 4, so you cannot able to, if you want to take the equation from here, so from here this is the equation for eigenvector. So if you want to get the eigenvalues and eigenvector, you need to, how can you do that? So from the equation ax equal to lambda into x. So lambda is a scalar quantity. If you want to convert it into a vector quantity, what we do, we can multiply it with the identity matrix, right? So depending upon the dimension of A, we will multiply with it a identity matrix. So it will be AX equal to, because 1 identity matrix is always 1, so it doesn't change the overall result of our system. So this will be x. So now the dimensions are matching, so you can do the operation. So a minus lambda I into x will be equal to 0. So to get the x, so if you want to get the eigenvector from a system of A, first what you have to find? First you have to find eigenvalues. So if you, so this is the equation, okay? So from here, this is the first step, from here this is the first step, and from here we are coming to here. So this is the equation from where you are going to get the eigenvector x. So from this equation, first you have to find lambda. So if A is given, from the equation you have to find lambda, that is the eigenvalues. Then getting after eigenvalues, you can able to get the x, that is the eigenvectors. You can get the x. Okay, so in this way we can get eigenvalue and eigenvectors. I will give I am going to make another video on the example of eigenvalues and eigenvectors. So I am completing this video, ending this video at this point. Happy learning.